Hello everyone, today I'm going to be doing this 9 bridges project because it's a very interesting example and there's a few lessons to take from this project, and also I really like it as an architectural element. It reminds me of the Mosteiro dos Jerónimos in Lisbon, Portugal, where I'm from. This ceiling structure is just an amazing piece of architecture. It's a great place to visit as well if you can. Definitely recommend it. But anyway, I like the comparison, but this is the one I'm going to model in Revit. And I have already set up the project a little bit. I created a few reference planes, placed an image on an elevation, tried to get the boring part out of the way so I can start straight away. If we go in Revit and we do a new family, to a generic model pattern based, and if we select the surface, we can see we only have these patterns. And I have a colleague at work that has asked about how could we create some custom patterns, and in this video I'm not going to address that yet, probably a next video. But this is one of the ways, because we don't have that pattern. We have similar things, but they don't really do what we're looking for. But what I thought for today is that I would use this rhomboid pattern, because in reality we could understand two grids there that then can have that triangle as a part of it, so the pattern doesn't need to be exactly. I just picked this one and we'll see how it goes. Now we're going to build a structure for our panel. It's just placing point in the middle here and in the middle on all these lines. Can then create spline like that. Another way of doing it is just start with the reference line, create a spline, and just place it like that. And I'll just place a few points more to host our profiles. So the way it would work would start by going into a new family, and we're going to choose metric generic model adaptive. I'm going to place a point and make this point adaptive. Let's draw a rectangle that will be our profile. And sometimes these points have weird behaviors, so although this is not, shouldn't really matter, sometimes it's good to have them there. It seems to behave better. So if I place it like that, and now I dimension it so that this is always going to be centered, and I create two parameters. So I can say L and height. I'll just name this, save this family. I'll just replace that one that I already had. Of course, this is a family that you'll use a lot of times. You want to save to reuse. So now if I load into the family, and let's place it. So best way is to use the set tool. Make sure we have the right reference plane. So again, I just use my shortcut for set work plane, and for now it will work. We can make it 100, and we can create form of these. Another thing that you want to do is take the visibility off so that you don't see those lines. If I load this into the project that we had started, I can just create a new mass just to test. So in place mass, let's just do a line and create form. If I then divide this surface, come to our rhomboid, we have the family one. So the thing is, this needs to be squares. We can adjust the thickness later or anything, but yeah, this will work. This is the type of family that we're going to use, and this is the pattern that we want to use. So now if I delete this, I don't want to use it just as yet, and I'm going back to plan view. I have already created these reference planes and created the red lines on the places that I thought would be the centers from the columns that go down from the roof structure. Let's try now create our surface. So if we start the surface, we make it that our reference plane is level 0. We can start with the reference line. It's always better for us to edit the surface later. And let's just place our points. Okay, what I would do now is just select these and copy them. And I would do that the same amount of times as I did before. So I started 1 and then jump every 2. Well, for now, for testing, let's just do 1 here. So if we select all, we can Windows tile so we can see what we're doing. We can see that the center of our columns will be here. So let's just pick these. Let's come in the 3D view and move those points down. If you want to have a better look at the surface and what's happening, we can select it and give it a different material. So we see just by dragging that one down, we have a hole here that's very square, and not only the square is doing all these bumps, because this process is so manual, I'm not sure how accurate it would be. So if we keep moving things, well, we could actually come here, select the 4 points around the centers, so we can try and move these a little bit down. So let's try just in this one, keep moving things until we get something better. After a while, we can think we're achieving a pretty good result. If I look at it though, I think I can still see a square. It can be improved by lowering these two. Maybe I would prefer to lift the corners. Can finish the math to see if I can see better. And we can come to a point where we think it's quite good. But because this is always like a manual process, it's not really great. The only way that I think that this would really be a nice smooth circle, it would be if it would be a revolve. So not really great. And the reason is that Revit, although we're trying some interesting techniques, it's still, this is not this spline modeling. What I did then is open Fusion 360, and I did the same thing in Fusion. So in Fusion there is a very interesting tool that we can use. It's the inspect tool. We can check the curvature of these surfaces, and these are to analyze spots where the curvature changes more suddenly. So it's very interesting. We can swap between them and try to find what we want. That we can use our curvature comb now, and we can see that we don't have a perfect curvature around here. If we look at it from an elevation, you'll see that it's doing this weird thing. But if we actually look from the top, it doesn't look as bad. But it is doing something odd. In reality, this surface has 2 directions, just like Revit. Although in Revit, it's the same thing. One is the direction of the loft, because our lines are along this way, the loft has this direction. The other one is the direction of the splines, that's along the points. We can actually bring this surface into Fusion. If I finish this, and if I do File, Export, and I'll export to SAT, override this Revit surface, I go back into Fusion, and I will import. Use the upload tool here. So I've done it, I have it here. I just need to bring it, and we can look at it here as well. But what we can do is, before we bring it into Fusion, we can actually see it here. If I edit in place, come here to my plan view, and I'm gonna draw a circle too, just like I did in Fusion. And here I can create a void form and make it cut through our face. Immediately see that our surface is not really that smooth, because although in top, because our cylinder void cut through this face on top, it looks like a circle, you'll notice that this is not really a smooth concentric movement of the surface. And because I have this void here, I could actually try to change it here, try to make it get smooth. This void can help us analyze it better, but I've played around with it quite a bit. It is really hard to make something smooth. So actually it's not that bad. If we go and check it now in Fusion, maybe we can have a better idea. But if we export as SAT, if this one, I can make a second Revit surface too. And I'll go back in Fusion and I'm going to upload. So select files, select the Revit surface 2. We come here, the file that we uploaded will be here, we just have to drag it. And we can say OK here. So let's use our curvature column. So if we look at the ones from Fusion, it has these 4 corners that you can see that something odd is happening. But the one from Revit is actually not really that bad. I don't know if I wouldn't prefer using the one from Revit. Although this surface, the Fusion surface, was a lot quicker to create. But the Revit one is actually not bad. But I'm actually going to try and bring the Fusion surface. And just because if you find it's quicker and you can achieve a better result, you can always do it from here. It will work the same way as doing the surface in Revit. So I'm gonna try this way. I'm going to export. I'm gonna call it Fusion. And I'm going into Revit and I'm gonna create a new mass. Then I'm gonna link CAD, select the Fusion surface, and I'm just gonna move it to the grids that I had created before. So after I place it here, we can have a look at it in 3D. And the great thing that probably many people don't know is that a surface created outside of Revit, if you bring it in Revit inside an in-place mass, you can still have a lot of the features as if this was a normal mass. So this one, I brought a SAT file from Fusion, and I'm able to select and use the tools divide surface. So if I untick the UNV grid and I use intersect list, I can select all my reference planes, and this way my grid behaves exactly the way I want it. If I would just use a divide with a certain distance or a certain number, I would get a very different result. So if now I go into the family that I created before, so if I have it here in the project, I can select the pattern and select that family. And we can see that a few panels failed, but that's fine. Let's not worry about that now. So if I notice that there is a few more things that are not really working that well, but we'll worry about that later. So if I come here in this section, and if I draw a line, notice that the panels are these straight lines, because the panels don't round up with the face. You'll see that I created this family on top of these adaptive points. Each of these reference lines is created by 3 adaptive points, which make that reference line a curve rather than a straight line. So I used the same technique as before. I just toasted the profiles and lofted the form. So I'm going to load it into the project. Right now I have to place it in a different way. Turn on the nodes, so I have a snap to the grid. I can just come here, place my 9 points. There you go. So I'll just select this and use the repeat command. So right now we still have a few missing panels that didn't work, but it's fine for now. If I go back in section view, and I can see my panels form a smooth curve, so they are going along with the surface. So this is much better. In this case we can still see a few errors or behaviors that we wouldn't want to see. For instance, this panel, you see that this curve here is not really what we wanted. I can figure why, and I could fix it or look into that. But for now we have another problem that I wanted to show you. If I just select these and isolate, you'll see that the frames are overlapping and they don't seem quite right. If we take a look at this in section, you'll see that maybe this profile is oriented the way we want, perpendicular to the surface, but the other one clearly isn't. So the reason for this is, for instance, when we do this family, we host the family on points. In these points we tell them that they are oriented to host XYZ. So it means that when we place a point here, the Z value should go there, the X should go there, and the Y should go there. And this is what we were looking for, host XYZ. Even if all our adaptive points are host XYZ, and they are working like that, the way we want, but in fact our family is created by points hosted along these, but then by reference lines. So if we have all these points here, and if these adaptive points create a reference line, and it creates a reference line like this, then our profiles that create the form are again points that are hosted on this reference line. So although this point here, hosted XYZ, is doing this, exactly what we want, the point that's hosted on this reference line doesn't recognize this fall here, this orientation. It only recognizes the reference line, so the way it's hosting, it's doing Z this way, X maybe perpendicular to the line, and Y. So again, this host is different from this one. The frames that we wanted them always perpendicular to the surface, which means that we would only be able to use these points and not any point that's hosted to the reference line within the family. So this makes it a little bit more tricky. So what I did next, I did do profiles on these points that hosted like that, so never using a reference line, and then I just selected the three of them and create form. It should give me a profile oriented the way I wanted. And because it didn't work, I'm not going to waste a lot of your time looking at the way I did it, because it didn't work. What I got instead was that Revit crashed, and it crashes every time that I try to bring that family into here. I have the adaptive component family with only the profiles, the way I was saying. Every profile is hosted directly on the adaptive point, not on the lines, making sure that the orientation of the points is host XYZ and not whatever the line it's going to be. And what I did is just select these profiles and create form. So this is independent from the reference line, and in theory it should work. Profiles should all be oriented the way we want, and the shape should have been created. And I believe that this is just some bug error. I could get it to work in a different version, or if I redo it. I did send the file to Autodesk. In theory it should work, and this is the way that we would want the structure to appear, so that it always turns the curvature of the surface. So to make this structure work, it's all about the orientation of the points and how they host on the main surface. So I'm going back to Revit, and all this was a very interesting exercise to understand how to model these surfaces and how to do a few things. But in this case, let's go back to the basics, do it in a really simple way. If I open a section view here, and I define the reference plane and draw a spline as a normal spline, the spline that allows me to control the smoothness of the curvature better. and draw a center line as well. By clicking both we can create the form. It's a revolve. And this one we're sure it's perfectly smooth. So if I create a void here and create more voids to cut the rest of the face, and I cut this geometry, I'll then have a perfectly rounded surface. This is the only way we can be sure. So I can just select these and divide and do the same thing as we did before. So remove the grids and set them by intersection. And let's start a new family. So a generic model adaptive, and I'm gonna place a point. This point I'll make adaptive. Place a profile on this plane here. We can change it to something that we think we want. And what I'm going to do is just copy this a bunch of times, the number of times that my grid is. And I'm going to use all these points. It really didn't take a long time to create, which will be a bit more boring to place one by one, but let's do this. And if you see here, the orientation of the points is instance XYZ, and if I load into project, this is what instance XYZ does. My points are being placed laying down for some reason, although here it's not like that. And if I change the point to host XYZ and load back into the project, and it will fail. And the reason why it fails, this is the right option and it should work, but the reason why it fails, if we have a look, is that all the profiles turn for the reason that it's host as an XY. So if north south is Y, west east is X. But if that's the case, then what we'll have to do is place it along this way. And if I start placing, I can see this warning sign telling me that it can't do it. And you'll know that it's not going to work. And if I place coming down, I see that it works. So I know that I actually have to start at the top. So I'm going to delete this one. And I'm going to start placing from the top down. So I'm always trying to figure what he wants to do. But if I place one by one, then I came to another point here that it warning sign again saying that it couldn't place it. So again, I couldn't place it anywhere. I don't understand the reason here. So I just hit escape, and I'm gonna place them one by one by selecting them, click new host, and place it again. And this time I was able to do it. So in the end, if I just select the whole element and hit repeat, I think this is the first time that this actually really worked. And the repeat gave me all but the last one that we can delete and replace if we need to. But if you see the way the ribbon starts to turn as it goes into the lower part of the surface, and you see that this is exactly what we want. And this is smooth and it's oriented the way we want, and finally we're getting something. So I just select and remove the repeat, and I'm gonna delete all of these because I'll have to place it again. So now I'm not gonna bother you again with this, so I'm gonna just place the rest of them manually using the repeat in the same way, and you can check the result. I didn't really finish the columns the way they should be, didn't want to spend much more time with it, but in the end I did achieve the result that I wanted, and I think it doesn't look bad. So thank you for watching, and see you next time.